to do some work. It's a wizard! No! I have come to defeat you. Expecto Patronum.
They're here. They're there, and they're here to stay. Dementors. The one creature wizard and muggle have left to dread. But wait, there is one hero who will rise to the challenge. Meredith Potter.
Wait, Meredith, the Potter. That's me. Yeah, you see, a couple days ago I was calling my friend on my phone, and all of a sudden the operator said the number I was calling was imaginary, and that I need to turn my phone 90 degrees and then try again. Just think if it was a payphone, you had to keep paying money for that.
That's great, wizard, but, like, can I kill you now? I mean, I had to listen to that horrible joke, stupid question at the end, and, you know, there's only so much that a single Dementor can take.
Stop complaining and let me finish you off.
I'd like to see you try.
Okay, you've asked for it. Time for me to kill you. Wait, Expecto Patronum, wait, why can't I kill you?
I stole all your happiness, hee.
Here are two pathetic characters, Meredith Potter, who can't do magic, and Janelle the Dementor, who is trying to kill the young Potter wizard. And so, after breakfast, they will battle each other and keep failing until one of them drops dead of boredom.
I'm so bored! Oh.
This film is not yet rated, and it's coming to a classroom near you.
Dementors are placed in the Forbidden Forest by the Ministry of Magic. Suppose that the Dementor population has a carrying capacity of 275 and a decay rate of negative 0.56 and a value of 100. When will the population reach 1?
B is the carrying capacity, B is the growth or decay rate, T is the time in years, A is the number found by using the limit value. So we're just going to put all the numbers into the equation. So we'll end up getting 1 equals 275 over 1 plus 100e to the negative 0.56 t. Awesome. So, in order to solve this problem, we're going to multiply the bottom on both sides in order to get it from not being the denominator anymore. And this will end up being positive because there's 2 negatives. So, 1 plus e to the 0.56. Okay, and then these will cancel out. So then we'll get 1 times 1 plus 100 e to the 0.56 t equals 275. And then we're going to divide both sides by 1. So you'll have 1 plus 100e to the 0.56 t equaling to 275. And then we're going to subtract 1 on each side. And then we are going to divide by 100. So we'll have e to the 0.56 t equaling 2.74. And then in order to get rid of the e, we have to multiply it by the natural log on both sides. So this will cross out. So then we'll have 0.56t equals to the natural log of 2.74. And then basically we divide both sides by 0.56. So the answer, well, the time will be 0.78 years. Yay!
In order to find the graph for this problem, first we should just start out with the basic grid. So we know for a fact that the population of the Dementors can't be less than 0 because you can't get a negative number. So that's where one asymptote is going to be. We also know that 275 is the highest that the Dementors can grow to. So there can't be any more Dementors than 275. So that's another asymptote. So the exact point that we were looking for was to find out when is there going to be one Dementor. And so because we were trying to find that, that's going to be the point on the graph that it's going to go through. And it'll give you basically your x-intercept, or y-intercept. And so from this, we can draw the graph. And because it's going to be a decay, it's going to be heading down. Ta-da!
PT equals C over 1 plus AE to the negative BT. So our equation is 1 equals 275 over 1 plus 229 to the 0.56 t. And remember that the 0.56 was a negative, but because that the negative b is, a negative, the two negatives equal a positive. So then you're going to times both sides by the denominator, so 1 plus 229 to 0.56t to both sides, and that gives you, on the left side, 1 plus 229 to 0.56t. And then on the other side, you just get 275. You want to minus by 1, both sides, which gives you on the left side, 229 to 0.56t equals 274. From there, you want to get 0.56t alone, so you're going to want to divide both sides by 229. So on the left side, you're going to get e to 0.56t equals 1.19650655. So then what you're going to want to do to get 0.56t by itself is times both sides by the natural log. So on the left side, with the exponent, you get rid of that, and so then you are left with 0.56t equals natural log 1.19650655. To get t by itself, you're going to divide by 0.56. So t equals 0.32 years. Plug 275 over 1 plus 229 to 0.56t minus 1, that's what you plug into your calculator, and then your graph looks like this. Okay, so then on here it just looks like this. And so your asymptotes, it's 275. And then for some reason it goes beyond 0, and then probably goes to negative 275.
Alright, so now we're going to try and find the decay rate. So we're going to start with the same equation we've been using. P of t equals c over 1 plus ae to the negative bt. So the decay rate is the b, so that's what we're looking for. So we first start out with 1 equals 275 over 1 plus 100 e to the negative b squared. And then to get rid of the denominator, we're going to times both sides of the equation by 1 plus 100 e to the negative b squared, which is the denominator. So we times that by both sides, so you get 1 times 1 plus 100 e to the negative b squared equals 275, because these two cancel out. So you're left with this. You're going to divide by 1 to get rid of the 1, obviously. So you're left with pretty much the same thing. So 1 plus 100 e to the negative b squared equals 275. You want to minus the 1 so you can get rid of that from this side. So we minus 1 on both sides. So this cancels, obviously, so you have 100 e to the negative b squared equals 274. Then you're going to divide by 100 on both sides to get rid of this, so you're left with e to the negative b squared. So from there, we get e to the negative b squared equals 2.74. And then to get rid of the e, you're going to times both sides by L of n, because L of n and e cancel then when they're together. So we're left with negative b squared equals ln 2.74 divided by negative 2, and you're left with a decay rate of negative 0.5. Alright, so now it's time to graph my equation. And first in the calculator, we're going to put in negative 1 plus parenthesis, 275, parenthesis, divided by parenthesis, 1 plus 100 e to the parenthesis, 2x, parenthesis, parenthesis. Plug that into the calculator, and this is what you get. Would you like to see it? Very beautiful. Alright, so we start out with our graph. It's a little high for me, so let's see if we can do it. So when you look at your graph, you begin with, this is about 275 up here, and then the x-axis would be considered 0. So if we make a dotted line, I guess I'm really short. And then it goes from here